Hello everyone, today we're gonna learn 5.4 triple integrals. Okay, so we learned single integral from Calculus 1 and Calculus 2, right? So basically, we found the area under the curve, right? But let's take a look, even though we have XY plane, right? So we have one-dimensional interval on the x-axis, right? So from definite integration A to B, right? So sometimes we are finding area under the curve or finding length, right? And we found the line integral too, right? Okay, now double integrals, so we learned that last time, right? So volume under surface, we learned that. And also we need to find the area if we have just integral dA, right? Okay, then both of them, both of R of a function is we might think height. So height times width, which is area, right? Then height times area, which is volume, right? Okay, this one just the area itself. Okay, so I thought this x-axis and we make a definite integration from A to B, right? So this is a one-dimension interval. And let's take a look. This is a rectangular region we had from A to B, C to D. That is for X. That is for Y, right? So that is two-dimension XY plane. Yeah? Make sense? Under the surface, right? So we had a bounded region D as well. So basically we have surface we cut, right? Like a rectangular region, bounded region. So this is a two-dimensional region, right? Okay, today we do three triple integrals, right? So triple integrals. We are looking for also volume, but this is for space. So let's take a look. Instead of rectangular region, yeah, and then we have a box. If we hear the box, there's a volume already, right? So like length times width times height, yeah? There's a volume already, right? So we have Riemann sum here. So same concept, we have a function. Now we have delta x, difference in x, difference in y, difference in z. That is, let's take a look. We can make this is length, width, and then height, right? So I wrote down there. Okay, then normally we have a Riemann sum. We make a sum of the function, right? But before we have a single integration, double integration, the function is acts like a height, yeah? But here, if we think about height, they're a little bit confusing because we have heights already from this volume, right? So we might think about just this function as a function or density. We don't think about the heights because in the rectangular box, already heights there, length, width, height, yeah? So we can just say that this is a continuous function on the space, and then we take only the rectangular box. We need to find the tiny volume from there. Make sense? Okay, let's do Fibonacci theorem again here. So we follow their theorem. So we knew that if we have this form, so we do integrate with respect to x, then we do integrate with respect to y, we do integrate with respect to z, we find the volume, all right? Okay, let's do it. So we do evaluate this function. All right. So x first, then we do treat y and z as a constant. Z equal to 0, z equal to 1, y equal to 2, y equal to 4. Okay, so we do integrate, so x squared over 2 plus yz is constant. So we can make x there, right? Keep the constant, yz squared x, yeah? And then we want to evaluate from x equal to -1 to 5 and dy dz. All right, so there will be z equal to 0 to 1, y equal to 2 to 4, and then 5 squared over 2 plus yz squared 5 minus, we have to calculate. All right. -1 squared over 2 plus yz squared -1, and then these dy dz, right? Okay, let's calculate. If we calculate combined like term, this and that, 25 minus 1, 24 over 2, right? Okay, now 5 and -1. Negative is positive, so it's 6 yz squared, right? Okay. So let's do it. Z equal to 0 to z equal to 1. Y equal to 2 to y equal to 4. So we have a 24 over 2 plus 6 yz squared. Now dy dz, yeah? Okay. We can simplify, right? So 24 over 2, which is 12. Let's write down. All right. So we do integrate to respect to y. Do a second. Treat z as constant. All right. So we have z equal to 0 to z equal to 1. 12y plus, we do integrate to respect to y. So z says a constant. So 6 is the actual constant. So 6 z squared y squared over 2 then, right? And we do evaluate from y equal to 2 to 4. And the z. Okay. Z equal to 0 to 1. So 12, 4 plus 6. 6 goes to, 2 goes to 6 3 times. So we take the 3, z squared, 4 squared, minus 12 times 2, and plus 3z squared, 2 squared. Yeah. Can you please calculate? So combining like term, right? So we have z equal to 0 to 1. So 48 minus 24, which is 24. And second term, 36 z squared. Did you get that? The z. Okay, now we want to integrate with respect to z. So we will have 24z plus 36z to the third power over 3. Now we want to evaluate z equal to 0 to 1. Okay, so we have a 24, 1 plus 12, right? So it's 1 minus locally 0, right? So what do you get? 36. Okay, now I want to ask you how many ways we can reorder the integrals, right? We can reorder the triple integrals. What do you think? Very good. 6. So 3 factorials. So 3 times 2 times 1, which is 6 ways. We can rearrange. Yeah. Okay. So let's do second one. Okay, so we have this example evaluate. So there is the function and then the rectangular box as shown above. Okay, so we have this function. We want to integrate with respect to x first. That means we treat yz as constant, right? Okay, let's do it. Yz is constant. Let me write down this one first. Z equal to 5, y equal to 0, 2, y equal to 3. We want to integrate respect to x. So x to the third power, and then yz is constant, right? So x to the third power 3. So we want to evaluate x equal to negative 2 to x equal to 1, dy dz. Okay, so z equal to 1 to z equal to 5, y equal to 0 to y equal to 3, yz 1/3 minus yz negative 2 to the third power. Oh, yeah, correct, right? And then dy dz. Okay, so we have z equal to 1 to 5, y equal to 0 to 3. We have -8 there, right? So this is a -8, negative is positive. So it will be 9/3. Yep. So let me do here then. This is 9/3 yz then, right? So there will be 3. Okay, we have a 3 yz dy dz. Yeah. We have to be careful. A little bit confusing, right? Okay, now we want to integrate with respect to y. Okay, then z is, let me write down. Do second, treat Z is constant. So we have 3 Z is constant. Let me write down Z first. 3Z constant, y squared over 3. I'm sorry, 2. And then we want to evaluate y equal to 0 to 3 dz. Okay, so then we have z equal to 1 to 5, 3 over 2z, then 3 squared minus 0. Yeah, dz. Okay, so z equal to 1 to 5. And then we have a 27 over 2z there. Okay, now we want to integrate with respect to z. So we have 27 over 2, z squared over 2. We want to evaluate it from 1 to 5. Okay, so there will be 27 over 4. And then 5 squared minus 1 squared. Can you please calculate? Okay, very good. 162. Yeah. All right. Okay, so we have triple integral over general region. Like double integral, we have a rectangular region, and then we had a general region, right? So same as a triple integral. So we had a rectangular box earlier. So here is general region. So let's take a look. So we have the function. They say that E is space between two functions and then project onto XY plane, which is D. Yeah. So this one has a function, this one has a function. Then they project onto the D, right? Okay. Then we have triple integration like this. Okay, now then, like double integration, we have type 1 error, type 2, not type 1 error, type 2 error. That's a statistic. Okay, type 1, type 2, right? So type 1, we had a vertical distance. That means vertical distance looking at the bottom and top, right? So that is consider y-axis, right? Okay, then we have x, have a constant, right? Outer integration. Okay, so let's take a look here. This is the XY plane. We do reverse like this. Oh, it's the same. I moved, but yeah. XY plane, X and Y. Yeah. Then this will be bottom. This will be top. Make sense? Okay. So we have this integration type 1 and type 2. Looking at this one, type 2 means horizontal distance, then left and right. And then we consider x axis, right? Okay, then y is constant. So looking at the x, y plane here, so if we do that, okay, I'm a little bit confusing. This is right, yeah? This is left, make sense? Since this is x, we're looking at this way then, yeah? No, I did a different way. So let me fix that. Okay, so I copied wrong. So if we have x and y, this is the left side and this is the right side, right? Make sense? Okay, so I fixed that. So we have this one for integration. Okay, so let's do the example. Okay, so we have this example. So triple integral, we need to evaluate, and we have a function and the solid tetrahedron bounded by planes. So x equal to 0, y equal to 0, z equal to 0. So I made mention that use this one as a lower limit later on. And then we have another function, right? So we are using this one. Okay, we solve for this one, z, then we have this one. So this will be upper limit later, yeah? And then we have function y equal to 1 minus x. So how we get the y equal to 1 minus x? From this function, we set z equal to 0, and we solve for x. Or you can do solve for x, and you can find the function there too, right? So look, how do we set it up? Let me set it up. Okay, so z first, because we have a two function of z. So we have 5x minus 3y. This is a function, original function, and then dz. So we are using the lower limit from z equal to 0. Upper limit will be z equal to 1 minus x minus y. And since we have a function as a y, so we are using dy. And then lower limit y equal to 0, y equal to 1 minus x. And then dz will be, I'm sorry, dx will be the last. So x is the first one. Is oh, you cannot see. First one is lower limit is 0. And we notice that this is the x, right? So x equal to 1. And also we notice that when x equal to 1, y equal to 0. Yeah. And then we can plug in anything. We get the 1, 0, 0 or 0, 1, 0, 0, 0. Yes. So that will be x equal to 1. So every time the last integration must be the limit as a constant so that we can find the volume, right? All right. So we set it up. Let's do the first. And we treat x and y as a constant, right? All right. Let's do it. So this is constant. We keep the constant, and then we do integrate with respect to z. So we put insert z there, right? Okay. So we have x equal to 0, 2, 1, y equal to 1, 2, 1 minus x, 5x minus 3y is the constant, and then z. Yeah. Okay, we want to evaluate z equal to 0, 2, z equal to 1 minus x minus y. All right, so that would be x equal to 0 to 1. And y equal to 1 to 1 minus x. So we have 5x minus 3y and 1 minus x minus y, right? And the rest is 0, dy dx. Yeah. Okay. So let's distribute. So we have x equal to 0 to 1, y equal to 1 to 1 minus x. We do distribute to 5x minus 5x squared minus 5xy minus 3y plus 3xy plus 3y squared. Yeah. So the y dx. Okay, combining like term. Okay, so what can we do that? Only this one, right? So negative, this is negative 2xy. That's it, right? Okay, now, let me write down. Okay, so let's do it. Let's do that. We do treat. Do second treat x as a constant. Oh, little bit confusing. Okay, let me write down then. Let me rewrite. So y equal to 1, 2, y equal to 1 minus x. So we have 5x minus 5, maybe orange. It's okay. So 5, it's negative. So let's just rewrite it this way. Minus 2xy minus 3y plus 3y squared dy dx. Yeah. Okay. Okay. That's confusing. Okay, now x equal to 0 to 1. We want to integrate with respect to y, so x is constant, so 5xy minus 5x square y minus 2xy square over 2 minus 3y square over 2 plus 3y to the third power over 3. And then we want to evaluate y equal to 1 to 1 minus x dx, yeah? All right. So we have 5x, 1 minus x, minus 5x squared, 1 minus x, minus x, 1 minus x, quantity squared, minus 3 over 2, 1 minus x squared. Need a space. Ooh. The last term plus 1 minus x to the third. And then 1, right? So there will be minus 5x 1 minus 5x squared 1 minus x 1 minus 3 over 2 1 plus y to the third, which is right 1. Yeah. And then the x. Ooh, lot of algebraic work required. Okay. What's the best way? Let me see. Okay, so I made a mistake. So this one is supposed to be 0. Huh? Yeah, here is 0, not the 1. Why didn't you tell me? Okay, so this one is 0 locally. So we don't need this one. Yeah. Okay. So dx. All right, distribute. 5x minus 5x squared minus 5x squared plus 5x to the third power. And then this one, we have x 1 square minus 2ab, so 2x plus x squared, right? And then distribute. So that will be minus x plus 2x to the second power minus x to the third power, right? And then we keep the rest. Okay. Combining like term. Okay, so we have cube. So 4x cubed, and we have squared. So we have negative 10, negative 8x squared. We have x positive 4x. And then we keep that, the rest. All right. We do integrate respect to x, right? So 4x to the fourth power over 4. 8x to the third power over 3 plus 4x to the second power over 2. Okay, so what about this and that, right? We want to integrate negative 3 over 2, 1 minus x squared, right? Dx. Okay, so if you cannot think about easily, right, use sub, right? So, but I recommend to this method. You This is a use sub method. U equal to 1 minus x derivative negative dx. Yeah. Okay, then negative du equal to dx. So we have negative 3 over 2. We put the negative and u square dx. Yeah. So there will be positive u to the third power over 3 plus c. So there will be u was 1 minus x to the third power over 2 plus c. Yeah. So what I do, this method here, I can see that if we derivative, then we have to have a negative sign, right? So I can see easily plus 3 over 2, and then make integrate. So 1 minus x to the third power over 3, yeah? And plus, also this one, if we integrate, we have to have a derivative inside the integral, right? So we make a negative, and then 1 minus x integrate. with the power rule, so 4 over 4. And then we want to evaluate x equal to 0 to 1. Yeah? Okay. Now, so we have 1 minus 8 over 3 plus 2 plus 1/2. Locally is 0 there, right? So this is 0 and also 0. Yeah? Minus 0. So we have 0, 0, 0, 0, and then last two terms plus 1/2 and minus 1/4. Yeah, it's okay. All right, can you please calculate? Oh, did I make a mistake here? Hold on a second. So do you get 1 over 12? Okay, very good. Okay, so we have this problem. Find the volume, right? Pyramid has a square base, that, right? And then vertex at 0, 0, 1. All right, so I made a note here, since the vertex at 0, 0, 1, this means z increased from 0 to 1, since z equal to 0 for all four vertices here. So I label, right? So this one is 1, negative 1, 0. This one is negative 1, negative 1, 0. This one is 1, 1, 0. This is negative 1, 1, 0. So we can see that all the z coordinate is 0, right? Okay, now we have vertex at 0, 0, 1. This called apex. Yeah. So this one, so we z increase from 0 to 1, right? We can see that. All right. Now we have also given information. So we have a cross thing here. So we have this is x, this is y, right? So that is given. All right. So from the given, we have negative 1 and 1 and negative 1, 1 as well. So we knew this is x, this is y, xy plane, right? Okay, so I'm gonna show you the equation. So this one we can set it up. X equal to negative 1 plus z, and we can set it up upper limit x equal to 1 plus z. How? Look, since we said that z increased from 0 to 1, right? So when z equal to 0, let's take a look. Then x equal to negative 1, x equal to positive 1, because this is 0, right? Can you see that? That's how we got here. Yeah. Hold on 1 second. This is the one, right? Yeah, this is the same as 4y. So let's take a look. When z equal to 0, we have y equal to negative 1 plus z, y equal to 1 plus z. Yeah. So when z equal to 0, we have y equal to negative 1 and y equal to positive 1. So this is also that, right? Okay, this equation, yeah, it works. Yeah. Okay. So we can set it up the limit, right? So boundary. So E, which is x, y, z. And then z is between 0 and 1. Y is between, I just want to write down the function, the equation. So, which one first? This is lower, -1 plus z. And this is positive, right? Yeah. Okay. And the x, we have, let me make a little bit smaller. Oop. Oh my gosh. Come on. Okay. So x will be same as y, right? So x between -1 plus z and 1 plus z. Yeah. Okay, let's set up the triple integration. So we can see that z is the last because z has constant, right? So z equal to 0 to 1. And then we can do either one, y and x. Let's do y first. -1 plus z, y equal to 1 plus z. And we have x equal to -1 plus z, x equal to 1 plus z. And we don't have a function, right? Okay, just leave as a function, as one, right? And then we set it up dx, dy, dz. Okay, now let us integrate respect to x first. Then there's nothing y and z, so I can skip the word. All right, now z equal to 0 to 1, y equal to -1 plus z, y equal to 1 plus z. Integrate with respect to x, so we have x, and then we want to evaluate x equal to -1 plus z, x equal to 1 plus, oh, did I say that? -1 plus z and +1 plus, right? Y dz. Okay, now we have z equal to 0 to 1, y equal to -1 plus z, y equal to 1 plus z. So we have 1 plus z minus -1 plus z. Yeah, dy dz. Okay, now z equal to 0 to 1. And y equal to -1 plus z, y equal to 1 plus z. 1 plus minus, which is 2, right? So -2 minus -z. So 2 minus 2z dy dz. Yeah, okay. Now we do integrate with respect to y. So do second. We treat, there's no x, so z as constant. So we have z equal to 0 to 1. And then integrate with respect to y, so 2y minus 2z is constant, so 2zy, right? And then we want to evaluate y equal to -1 plus z, y equal to 1 plus z, right? And the z. Okay, now we have z equal to 0, z equal to 1. Okay, so 2 minus 2z, we can just keep that, right? So 1 plus z minus -1 plus z, evaluate, right? So this is better. Okay, let me do better way. Yeah, since this is a constant, we keep the constant and then y. How about that, right? Better? Okay. All right, now I don't make a mistake, right? Okay, so the z. All right, so this is the same as the earlier, as x, right? So we have a 2 minus 2z there. Okay, so that will be z equal to 0 to z equal to 1. So 2 minus 2z squared dz. Yeah. Okay, now integrate. So this method. Okay, so look, we want to integrate with respect to z, right? Then we have to have chain rule inside this one. So we make like this way, right? So how do we do? 2 minus 2z squared. So we're gonna use the power rule later, but we have to have a like a -2, 2 minus 2z squared. I just insert -2 because we have to have a chain rule inside there. Since I insert, kind of make one, -1 of 2 outside of interval, right? So then we can use, we keep this one here, -1/2, then use the power rule. Two minus 2z to the third power over 3. Yeah. This is much easier than you sub. Or you're not familiar with this method, you sub let u equal to 2 minus 2z. Yeah, then you can do the rest. All right, so that will be, we have a -2 and 1/3, 2 minus 2z to the third power. And then we want to evaluate from z equal to 1 to 2. Oh, I'm sorry, 1, right? Okay, now we have -1/6, 2 minus 2, z, 1, 1. So 2 minus 2 minus 0, yeah? Yeah, third power, yeah? Okay, so this is 0. So we will have -1/6 minus 2 to the third power. Okay, multiplication, right? So inside. So what do you get? This is a 4/3. Is it okay? All right, we have a couple more problems. So let's do it. So this is a little bit hard, right? But the two problems just straightforward. Set it up everything for you. Okay. Okay, so let's do this problem. So we have this one. So let's integrate with respect to z first. All right, so we just follow that. X equal to 0 to 1, y equal to 0 to x squared. And then x, y is constant. Keep that. Z squared over 2. And then we want to evaluate z equal to 0 to y squared, dy dx. Yeah. Okay, now x equal to 0 to 1, y equal to 0 to x squared, then xy is constant, and over 2 is constant. Z squared is 2 y squared squared minus 0, yeah? Okay, now x equal to 0 to 1, y equal to 0 to x squared, and x to the fourth power, and then x to the fifth power, right? So x over 2, y to the fifth power, dy over dx, not over dx, dy dx, yeah? Okay, so let's integrate with respect to y second. Then we do treat x as constant, right? All right. So that will be x equal to 0 to 1. Integrate with respect to y. So we have y to the 6th power over 6. X over 2 is the constant. And then we want to evaluate y equal to 0 to y equal to x squared, right? Almost done. Dx, yeah. Okay, now x equal to 0 to 1, 12, right? So x over 12, and x square evaluate to the 6th power minus 0, yeah? And dx. Okay, so we have a power is 12, x to the second power raises by 6, 12 there, and 13, yeah? Okay, so we have x equal to 0 to 1. We have 1 over 12, x to the 13, very straightforward. So you calculate the rest. So we have 1 over 12, x to the 14 over 14. Yeah, we want to evaluate from 0 to 1. Wow, so lucky to have 1 and 0. So we will have 12 times 14 is 1 over 16. Yeah, or 160. Yeah. Okay, so let's do quickly changing the order of integration. We know how to change the right? So okay, so this will be last question for this section. Thank you so much for watching. Okay, we're gonna change the order of the integration, right? Okay, so we had earlier this straightforward, right? But now we want to change. So since we have y equal to x squared, then solve for x, then we take the square root of both sides, so plus minus square root of y, right? Okay, then this is y equal to x squared, and then we change the x, yeah? Then we notice that y is between 0 and 1, right? So we are using it. Look, we have z equal to y squared, so this is y z plane, yeah? Okay, then z equal to y squared. Then we notice that the y is also 0 and 1, right? Okay, now looking at the constant term, which is y, right? So we set it up, y is the last. So we have y is the last. So either one is okay. We can set up x first, z, or z then x, all right? Okay, so in that case, we do integrate with respect to x first. So let's do it. Okay, now we have y equal to 0 to 1, and then z equal to 0 to y squared. All right, so integrate with respect to x, so yz is constant, so yz constant, and then x squared over 2, right? And then we want to evaluate x equal to square root of y, and x equal to 1 upper limit, right? So the z dy. Okay, now we have y equal to 0 to 1, z equal to 0 to y squared. Okay, so we have yz over 2 is constant. 1 minus square root of y. Hold on 1 second. This is also square, right? So, make sense? Okay, now we have y equal to 0 to 1, z equal to 0 to y squared, and then yz over 2, 1 minus y there. Yeah. dz dy. All right. Dz. We distribute it. So we have, let's take out the z, and then we have, hold on one second. So we can do that, y, right? Over 2 minus y squared over 2. Is it okay? Because we multiply, then yz over 2 multiply yz y squared over 2, right? And then I want to integrate with respect to z, yeah, and then this is a constant, right? Okay, so there will be the second, then we treat y as constant. All right, so there will be y equal to 0 to 1. Oh, yeah, right? So z, y over 2 minus y squared over 2. We can do that too. This is a constant and z squared over 2. So we want to evaluate z equal to 0 to y squared dy, right? Okay, then we have y equal to 0 to 1, y minus y squared over 2. And then evaluate. So y squared to the square over 2, and then 0, right? And then dy. Woof. Okay, let's do that. Y equal to 0 to 1. And then 1 over 4 constant. All right, then this is 4th power. The right side is a 4. And then we do distribute. So y to the 5th power minus y to the 6th power then, right? Okay, now the last one, integrate with respect to y, so 1 over 4, y to the 6th power over 6 minus y to the 7th power over 7. Then we want to evaluate from y equal to 0 to 1. Okay, please calculate. So we have 1 over 4, 1 over 6 minus 1 over 7, locally 0, others? Okay. You get 1 over 168? All right, same as earlier, right? Okay, thank you for watching. I will see you in the next section. Thank you, bye-bye.